Hey guys, welcome back. In this video, I'm going to teach you how to evaluate logs without using a calculator. So how do we do that? The way that we read this is we say 3 to what power makes 9? 2. The way that we read this is we say 2 to what power makes 8? 3. The way that we read this is 9 to what power makes 81? 2. The way that we read this is we say 2 to what power makes 64? 6. And what you guys could do for these problems is you can set your expression equal to x and make it an equation. And you can say lift and shift. What do you mean by that? Lift what's on the floor and shift. Swap those and make one an exponent. Okay? So 3 to what power makes 9? 2. Okay, what about this one here? Well, you can do it by lift what's on the floor and shift. Okay, so let's go to a new page. And so that's why our answer is 3. What about this? Ready? 7 to what power makes 1? Well, did you guys know 7 to the 0 power makes 1? Right? 7 to the 0, 1. 8 to the 0, 1. A billion to the 0, 1. A to the 0, 1. So x equals 0. We're going to lift, and shift. 5 to the x equals 1 over 25. Okay? 5, this is the way that we can look at this. 5 to what power makes 25? 2, right? That makes 25. Anytime your number is in a fraction or it's 1, right? Over, we're going to give it a negative. Isn't it true that 5 to the negative 2 is 1 over 25? So my answer here is negative 2. 8 to the x is equal to 1 over 64. 8 to what power makes 64? 2. And then because it's under 1, it's negative 2. Okay, let's try another color. Lift and shift. Lift the 25. Okay, now I'm kind of stuck here, right? So what I'm going to do here is I'm going to say, I'm going to get them down to common bases. I can rewrite 25 as 5 squared. And I know 5 is 5 to the first. When the bases are the same, we kind of ignore them and set 2x equal to 1. So let me get rid of this numerator. If you guys need to ever stop the video, just stop it. Okay. So let me get rid of this. Okay, so now I have 25 to the x equals 5. 5 squared to the x equals 5 to the first. Power to a power, we multiply. And since these two guys are the same, you set the numerators equal to each other. So x is equal to 1/2. Right? So you can say 25 to what power makes 5? Isn't it 25? Isn't the square root of 25 5? What is the square root as an exponent? 1/2. The final question I have here is actually a trick question. Okay, guys can pause the video if you need to. The way that you read this is you say 3 to what power makes 9? 2. 2 to what power makes 8? 3. Now take a look here. 2 to what power makes negative 8? 2 to what power makes negative 8. Did you know that this is an exponential function and exponential functions could never be negative? Okay, so think about it. You might say 2 to the third. Well, that's 8. You might say 2 to the negative third. Well, that's 1 over 8. So no value will ever give you this. So what I'm going to tell you here is that logs cannot hold negative values. This number here, whatever's in here, must always be bigger than 0. Their domain is from, I should have not put x, I should put, their domain is from 0 to infinity. And their range, you're going to see that it's all real numbers. But for those, I will show you this a different time. But basically, you get all, this is what the graph looks like. You get all of these numbers down here and all of these numbers up here. It's concaved down. Okay, in this part of the problem, I have this equal to this. And so how do I solve for x? I'm going to just set the numerators, right? Think about it. If this is this, the only way these could be equal is if their exponents match. So I'm going to minus x. And then you're done. Well, what would happen if these do not match? How do I solve for it? Well, you make them match by getting them down to what we call common bases. So 25 is 5 squared. So you just exchange that, but make sure you put your parentheses. 2x minus 1 is equal to 6x minus 2x divide by, and we get x to equal to negative a fourth. You get them down to the same base. Okay? What about here? Same story. You're trying to solve for an exponent. Let's get them down to the same base. What is 64? It's 4 to the third. Now that these match, you sort of ignore it. Don't cross it off, but basically you're crossing it off mentally. You add 3, you get 4. You divide by 5, you get 4/5. So that's your answer. So how do we do these last two problems? We are going to lift and shift. That's how we get rid of logs. We lift and shift. We lift the 8 up and we shift. What's 8 to the second power? 64. What does negative do? It puts me under 1. How do we solve? Well, you got to get rid of log. How do we get rid of log? We lift and shift. 5 to the fourth, 625. You lift what's on the floor, and then you shift those two. Okay, and I believe this is lift and shift. What number squared makes 9? 3. Some of you might say, so does a negative 3. This could never be a negative value. Never. Okay? Lift and shift. 4 to the third makes 64. Okay? No calculator. We're going to lift and shift in order to get rid of this log piece. You're going to lift and shift. How do I read this? No calculator. How do I read this? What number do I multiply 3 times to give me 27? That's 3. And then 3 to the negative 5. Well, that's going to be 1 over 3 to the 5th. And remind yourself what that means. It means 3 times 3 times 3 times 3 times 3. That's 9. That's 9. So that makes 81. 81 times 3. So that's going to be 1 over 243. Okay? So that's our video for today. We're going to lift and shift in order to get rid of logs. Have a great day.